Either click on the link to join the Pear deck, or go to joinpd.com and type in the class code. It looks like we have 13 people connected. So you can click on that link to join, or joinpd.com and type in this code. So I'm going to go ahead and start everything up. If, again, at some point you get kicked out, just go ahead and click on the link in the chat, and that'll add you back in. So like I had said, this is some practice with voltaic cells. So we're going to go through some questions. You might be drawing arrows, typing in responses, but we've done this before. Just a way to practice and make sure that any questions you have might get answered, or you get to see the actual practice questions, so you have an idea as to what AP style questions might look like with voltaic and galvanic cells. So you have half reactions at the bottom of the voltaic cell here. And so I said, using the half reactions at the bottom of the voltaic cell, label the following. So you're going to label the anode, you can just use an A, cathode, use a C, salt bridge, and voltmeter. And then it says draw an arrow to indicate the direction in which electrons are flowing through the wire. So you can actually draw right on the slide. I know with your Chromebooks that might not be the best looking, but that's okay. But go ahead and draw right on the slide. Label A for anode, C for cathode, SB for salt bridge, V for voltmeter, and then draw an arrow to indicate which way the electrons flow. So I give you the half reactions at the bottom. So you'll see that Zn is going to Zn2 plus, and Cu2 plus is going to Cu. So think about those half reactions. Think about what is the oxidation half reaction and what is the reduction half reaction, because that helps to tell you the anode and the cathode. Good, I see a lot of people putting in arrows. Some people are changing colors. So again, use those half reactions to figure out what is the anode and what is the cathode. Remember that oxidation occurs at the anode, reduction occurs at the cathode. And then think about which way your electrons flow. Good, I see a lot of people drawing all over the slides. So remember, use the half reactions if they're given to you. So while some people are finishing up drawing their slides, if you take a look, Zn to Zn2 plus, that's an oxidation number of 0 to +2. And so that is the loss of electrons. The reactant is losing electrons. Zinc is oxidized. So Zn to Zn2 plus is oxidation. Cu2 plus to Cu is reduction. So Zn is being oxidized. Cu2 plus is being reduced. So based on that, you can think about what the anode and cathode would be. So we'll look at some people's responses. So we see anode, cathode, salt bridge, electrons go from the anode into the cathode. So everybody here is showing the electrons moving from the anode to the cathode. Salt bridge is what connects it in between. And when people realize that I'm showing their responses, I see some nice pictures being drawn as well once people get done labeling everything. But if we take a look, the next part of this. So based on what we just said, the zinc is the anode. The copper is the cathode. So now what I want you to do is I want you to draw an arrow to show the migration of the anions and cations in the salt bridge. So remember, for a galvanic or voltaic cell to work, these two solutions need to remain neutral. If they're not neutral, the circuit won't run. And so the salt bridge allows ions to travel into the appropriate half cell to stay neutral. So you should have two arrows. You're gonna have one arrow for K plus, one arrow for NO3 minus, and show which way are they each moving. Your cations move one way, your anions move the other. Remember, electrons don't go through the salt bridge, just the ions within your electrolyte. So remember, zinc we said was the anode, copper was the cathode. So once you've labeled, or once you remember that you have anode and cathode, then draw an arrow from K plus, which direction that will go, and NO3 minus, which direction that will go. Yeah, so I see a lot of people drawing. Okay, so if we take a look at some of the responses, notice we have the anions going into the anode, cations flowing into the cathode. Make sure you're specific. So all of these responses, notice how we see the NO3 minus going into the anode, we see the K plus going into the cathode. So just make sure that when you're drawing arrows, that it's easy to follow. So you have NO3 minus going into the anode, K plus going into the cathode. So zinc was the anode, that's where oxidation occurred. Copper was the cathode because that's where reduction occurred. Good. So now we have just some short answer questions. We're going to go back and forth between some short answer and some drawing again. So this just wants you to answer the question about this galvanic cell. So remember, galvanic and voltaic cell is the same thing, but they give us this picture. This is from a free response question. So which half cell contains the anode? The left, or I should say the right or the left, and justify your response. So you can start with either right or left, but then make sure you justify your response and you tell me why. The important thing here is what they give you in this picture. They're showing you something that is really useful to be able to tell which half cell contains the anode. So a lot of people are noticing what's in red here, right? The electron flow. So check your notes. Which way do the electrons flow? They flow from something to something. Yeah, good. So I see a lot of people saying the left. And then I see people saying from the anode to the cathode. All right, so remember, electrons always flow from the anode to the cathode. No matter what, they flow from A to C. So that can be a reason. I know I see some people are talking about, you know, like NO3 minus going somewhere or K plus going somewhere. Just use the electrons. The electrons flow from the anode to the cathode. Therefore, the left half cell must be the anode. And so here's how College Boards scored this. These were their scoring guidelines. So the anode is the aluminum in the left half cell. So the left half cell is the anode. Electrons are flowing from left to right, which means oxidation is occurring in the left half cell. That's our reasoning. So here's another, this is the same picture, but now this is asking you what happens to the mass of the zinc electrode as the cell operates. And it says justify your response. So this is what we talked about in the do now. In a galvanic or a voltaic cell, over time, some things happen to the electrodes. So we just said that aluminum is the anode. So that means that zinc is the cathode. So what is happening to the mass of this zinc electrode, this piece of zinc? What is happening to that as this cell runs? And then it says justify your answer. So make sure you're giving me the answer, but then you're justifying. Right? And try to be specific if you can. Good. I see a lot of people giving the answer. And we talked about this in the do now. Okay, so I'm going to show a couple responses, and then we'll look at how College Board, the answer that College Board was also looking for. So a couple responses here. And so either one of these works. One is a little bit more specific, but both of these are still good answers. So the mass of the zinc electrode increases. So the first part of this is that it increases because the Zn2 plus ions that are in solution are being reduced to zinc solid. And that solid sticks to the cathode, right? So Zn2 plus is converted to a solid, right? Solid zinc, so the product is a solid, and the solid is deposited on the cathode. And so the cathode is increasing in mass. And so if we take a look, this was how College Board answered this. So the mass of the zinc half cell will increase because the aqueous zinc ions, those are the Zn2 plus ions, are reduced to zinc metal, which is deposited on the cathode. So you have to know where the electrons flow from and to, what happens to each electrode. So the cathode increases in mass, and this is why you want to be specific. And then the anode decreases in mass because the solid is being converted into cations that are floating in solution. Okay, so now we're drawing again. So this is the same picture again. We now know that aluminum is the anode and zinc is the cathode. And so this says describe the motion of the ions in the salt bridge during the cell's operation. So I said draw an arrow to show the migration of the K plus and NO3 minus ions. So two arrows again, one for K plus, one for NO3 minus. Think about which way do the ions from the salt bridge flow? Because one of the ions should flow one way, one of the ions should flow the other way. Good. And I see people labeling anode and cathode as they're drawing. Obviously on our Chromebooks, it's going to be a little bit different, but on like the actual free response test, you'll have it, right, paper, pencil. So label things. We could now label aluminum as the anode, zinc as the cathode. So we have oxidation at the anode, reduction at the cathode. And then that will help us think about the way that the cation and the anion from the salt bridge flow. And some people are using different colors to help them as well. Some people are just playing around with the different colors on drawing everything. So if we take a look at how College Board would have graded this, K plus is going to migrate to the right side. So the cathode, cations to the cathode, anions to the anode. So you're just drawing an arrow from NO3 minus toward the anode, an arrow from K plus toward the cathode. So now this was a free response question 4 years ago, I think. So it says a student is given a standard galvanic cell represented at the right that has a copper electrode and a tin electrode. As current flows through the cell, the student determines that the copper electrode increases in mass and the tin electrode decreases in mass. So although in this picture, they're not giving us the electron flow, they're not giving us half reactions, they are giving us the information that we need to figure out what is the anode and what is the cathode. So use your notes if you need to, which electrode increases in mass, which decreases in mass. So part A says identify the electrode at which oxidation is occurring, explain your reasoning based on the student's observations. And then part B, as the mass of the tin electrode decreases, where does the mass go? So take just a minute or so and answer both A and B. Good, and I see a lot of people starting by labeling both electrodes based on the student observations. And the nice thing about this is if you're not sure, you can always guess, right? It's not going to hurt to guess. But use the student observations. So I'll give you kind of a hint here. Remember that the cathode increases in mass and the anode decreases in mass. So that should help with part A. So I want to make sure we get through the last question as well. And I see some people are still typing. So just keep in mind what you typed, what you answered for this. Because I see that people are talking about different things here. I'm going to put one response up here. And I think this one response does a good job of answering these questions. And then I'll show you how College Board responded to these questions. So here's one of the responses that I just saw as I was kind of scrolling through everybody's. So oxidation is occurring at the tin electrode because it's decreasing in mass during the reaction. Now, this next part is the most important because we're now looking at the specifics. So meaning it's losing its electrons and the tin atoms are being converted to tin 2+ ions that are leaving the anode. So the tin solid is turning into tin 2+ ions that are now going into solution. And then for part B, the mass goes into solution as tin atoms are converted to tin 2+ ions. So we don't have mass that's going through the salt bridge or going through the wire. We have two half cells. The electrode itself, the piece of metal, is losing its mass, but it's just losing its mass into the solution. So the tin atoms are being converted to tin 2+. So here is how College Board responded to these. This is College Board's answer. So because the tin electrode is losing mass, tin atoms must be forming tin 2+. This is oxidation. That was part A. Part B, the atoms on the tin electrode are going into solution as Sn2+ ions. So as the mass of the tin electrode decreases, the mass goes into solution. Sn is turning into Sn2+ ions, which are then just going into solution. And then the last part of this question, this is the last question we'll look at. In the expanded view of the center portion of the salt bridge, so you have the box that says KNO3 salt bridge, it's kind of zoomed in. I want you to draw and label a particle view of what occurs in the salt bridge. So you're just showing me you have K+ ions and NO3- ions. Which way are they going? So in this KNO3 box, you can write out K plus and NO3 minus and show me which way they're going. So we've already said that tin, SN, is the oxidation half reaction. So that's the anode. So which way is K plus going and which way is NO3 minus going? So remember, your substances in the salt bridge are leaving the salt bridge into the half cell. You're not having things from the half cell go into the salt bridge, but the cation and the anion in the salt bridge are going out into the half cells to keep them neutral. Good, so I see a lot of people split it up into K plus and NO3 minus. I know some people are still drawing, but I just want to get to the next slide before the bell rings. So for part C, you can see the answer down in the right-hand corner. K plus is moving to the left because the copper half cell is the cathode, that's reduction. NO3 minus is going to move toward the tin half cell because the tin electrode is where oxidation is taking place. So you're just showing K plus and NO3 minus. So just a couple quick things, and then the bell's going to ring. The only thing over break that I'm asking you to do is watch video 10.7. It's already up in Edpuzzle. That's the only thing you need to do. If you didn't watch the particulate view of the voltaic cell that I posted on the stream of classroom yesterday, just take a look at that. I made it with the little particles again. It was actually showing what's happening as the cell is running. It's in YouTube, so you can speed it up if you need to. Mastering is already up as well, but that's not due until the 12th. So really the only thing for overbreak is just to watch 10.7